Well, this is our first Deep Sky videos since we finished the Messier catalog.
It's your first.
My first. Our first.
Yes.
Together. It's a collaboration, yeah.
Yes.
And since the Messier catalog is a catalog of things that aren't comets, and we're now allowed to talk about whatever we like, I thought I'd choose an object that is actually a comet.
Oh, Messier would be turning in his grave.
Yeah. Well, no, he'd be excited. He wanted the comets, right?
Actually, good point. All right.
Yeah.
What
So the comet I've chosen is Comet Hale Bopp because it's the one I have an actual personal connection to. I actually remember seeing it in the sky. When I was a kid, growing up, really interested in astronomy, and Comet Halley came around once, as it does, once every 76 years. And I remember being bitterly, bitterly disappointed because we couldn't see anything. It was just kind of a non-event. So I was this disappointed little astronomy kid. But then unexpectedly, a new comet was discovered, and it was discovered while it was still out past the orbit of Jupiter, which made it quite unusual, indicated it was probably quite large. Better yet, it was going to pass sort of quite near Earth, so we were going to get a really good view as this cold frozen nucleus came close to the sun, started warming up, outgassing, and doing its whole comet thing. And it didn't disappoint. So what I remember is the winter of 1996/1997. I was in my final year at university. I was living in a place where the skies were actually quite naturally dark. It was a very, very small town in the middle of nowhere. So very unlike Nottingham here, where we have a lot of artificial light, a lot of light pollution. It's very difficult to get a nice dark view of the sky from the city. But out in Sackville, New Brunswick, the skies were dark, and this was an object that just hung around in the sky for months. I remember walking home one night and just sort of turning the corner and looking down the street, and it was just hanging there in the sky. And we got an even better look at it. So I was really lucky to have this fantastic astronomy professor, Dr. Bob Hawks, who was a real influence on me and my career. And he took a bunch of us out in his car. We drove out into the marshes, into the countryside, and just went for a viewing party out there. So it was really, really spectacular.
Why was this comet so spectacular when some other ones haven't been?
So part of it is down to the sheer size of the thing. So observations, and it was continually monitored as it came into the inner solar system. So this is an absolutely massive thing. And as it got close to the sun, heated up, that results in outgassing. So jets were coming off different parts of the comet. It had a lot of very fine dust, which made this beautiful big display. And it was just a very close and very active comet, and very visible. It was well placed in the sky. For us in the northern hemisphere, I think when you, Brady, in the southern hemisphere wouldn't have had such a great view of it by the time it passed around the sun and then dipped down to your part of the world. But we got a beautiful show up in the northern hemisphere for several months. It's a long period comet, so we're not going to see it again for another 2,400 years. So it really, really goes a long way out into the outer solar system before it loops back. And like many long period comets, it does this on a very, very highly elliptical orbit. And it's interesting to think of a mental picture of it because we tend to think of the solar system being in a plane.
What, like your table?
Like my table, with the planets orbiting around the sun, more or less all with the same angle. But of course, space is really three-dimensional, and comets, like Hale Bopp, often come in from very oblique angles. It was coming in from the south, crossing the plane of the ecliptic, going over the top as it rounded the corner near the sun, and then plunging back down again.
It's way down south now. Where is it now?
So now it's about 40 astronomical units away. Now the astronomical unit is the unit that we use for solar system scale distances because it's the distance between the Earth and the sun. It's 40 times that away right now. Just to give you some perspective, the orbit of Neptune goes out to about 30 AU. So it's further away than Neptune from the sun, but in a completely different direction. And we can actually show you this because we've got a live solar system emulator which you can actually look up different objects, including Hale Bopp. Right, so I've set the date here to August 1996, and if I rotate this, you can see what I was saying about the angle. So the planets are all in a plane, but then you see, I hope, that this plunging orbit from Hale Bopp comes up and over, and if I animate this, with 1 second being 1 week, you don't see much. So I'll change that to 1 second being 1 month, and you start seeing it come around. It's now February 1997. If I pause it and zoom in, you can see just how close it came to us in the inner solar system. Not in any way that it was going to collide. Had it collided, it would have been absolutely catastrophic. The size of this thing was way bigger than the size of the asteroid that wiped out the dinosaurs. But the chances of that happening were very, very small. So instead, we just got this beautiful light show. If I change the date here, we can now see that it started to leave us on its orbit and head back into the outer solar system.
Presumably it hasn't got a tail and doesn't look spectacular anymore.
No, not at all. So the tail really only, or the tails, I should say. So here's the typical image that you think of when you see a spectacular comet. You've got this bright ion gas tail, and that's pointing directly away from the sun. So that's particles being pushed out by the solar wind. And then you've got this more visible dust tail that's often off at a trailing angle. This icy, dusty body is being melted, essentially, as it gets near the sun. The gases are pushing the material out, and then the solar wind is trailing it off behind as it continues in its orbit. So, this is an astronomer's view of a comet. But again, I just went through and found some images on the web, but this is what I remember. This is the view from the everyday person on the street. And it's not very often that, someone will just walk down the street and look up and say, even with no interest in astronomy, oh my God, what is that thing up there? And that's what we had for months and months with this. So that's what I remember about Hale Bopp. But you asked about what it's like now, and we're still observing it. And so I was really curious to see that in cycle 1 for the James Webb Space Telescope, there was a proposal that got time to go and observe Comet Hale Bopp. And so at that time, at the time of observation, it was far in the outer reaches of the solar system, and it wasn't this spectacular looking thing with a tail. It's back to being a frozen, icy body, but one that with the right instruments, we can still learn lots about its composition, about what kind of water is in there, what kind of organic materials are in there. And that helps us understand the conditions in the early solar system when objects like these were formed, and potentially whether water and organic materials were brought to Earth in the early part of the solar system formation.
Has it been imaged yet? Has it happened?
It has, yes, it has.
Can we see it yet?
Not yet, no.
Oh!
There's all I could find was a conference proceeding talking about the observations. I think the images probably wouldn't be very spectacular, but as with most things with JWST, a lot of the really meaty science is going to come out of the spectroscopy, because that's where we find out what it's made of.
Is this what most comets are? Is this just a remnant from that cloud of icy objects that are far, far away that just got knocked down towards us? What would be the origin of this, most likely? Yeah,
that's right. So, like most long-period comets, we think that they probably originated in the Oort cloud, which is this cloud of primordial icy material, in the very, very, very far reaches of the solar system. And every once in a while, some gravitational perturbation from a passing star or something might just nudge something out of that equilibrium state, and it starts plunging down into the gravitational well of the solar system. And that's why these orbits tend to be very long period comets. Very different from something like Comet Halley or some of the other comets that have been in the news that tend to just hang around essentially the inner solar system and come back every few years, or in the case of Halley's Comet, every 76 years.
So how come Halley's Comet has such a short period by comparison? Is it just a a gravitational fluke, or?
Yeah, I mean, it's all, once you enter into the inner solar system, you know, the complex gravitational interactions of the planets, particularly Jupiter, really can change a comet's orbit. They don't necessarily stay on the same orbit all the time. Something can be perturbed, captured, disrupted by something like Jupiter. Indeed, we've even seen comets, the famous Shoemaker-Levy comet. It was torn apart and then actually impacted into Jupiter. So, you know, the solar system is a gravitationally busy place, and things can get messed around and disrupted very easily.
When you think about this comet that was here thousands of years ago, it was here during your lifetime, and it won't be back for thousands more years. Does that make you feel insignificant?
This is something that astronomers grapple with all the time. I don't think it makes me feel insignificant. I actually feel like it gives me a little bit of perspective. That's what I enjoy about all of these big numbers and these large distances. It doesn't make me feel insignificant. It makes me actually feel like I want to treasure what we have here because it is so unusual and so fleeting. That's very philosophical, but you asked.
Have a look at the video description for more of us at Deep Sky Videos. Of course, we've got our 110 videos about the Messier objects. And if you'd like to learn one-on-one from people like Professor Gray, of course you could study physics or astronomy at the University of Nottingham. I'll put a link to that also in the video description.